Hello everyone, welcome to another lecture of control system on block diagram reduction. In today's class, we are going to see how block diagram simplification can be useful in efficiently representing your control systems. So a complex design of a control system can be represented in a much simpler form using certain rule sets that come with your block diagram reduction. So some of the rule sets that we will be using in today's class or we'll be seeing in today's simplification are the first one being a scalar multiplier. So a block or a system G1 here represents a simple multiplier. So it multiplies with your input A1 giving your output AG1. Now you have next a series of loops or series of systems G1 and G2 which is your multiplier and the output is given as G1 and G2. Next is you have an adder, you have a summer block where your G1 is sent to a scalar multiplier A1. So that is your AG1 or A1G1 in this case, and you have the other branch A2G2. So together on addition, they give you A1G1 plus A2G2. So these are simple operations, simple arithmetic simplifications that can make your block diagram look much simpler, and a simpler block diagram when taken to design will produce the same efficiency but a much lower infrastructure and at a much cheaper cost. So for the next rule set, we are looking at moving your branch to either before or after your system block G. So the first example is shown where your node is at the position shown by the red dot. It's before the system G, and the simplification is taking that node to a point after your system G, and that introduces a cascade block, or that introduces an additional block of 1 by G. So this may look complicated because in the previous stage our infrastructure was having only one block. At a later stage you are having two blocks, but in the overall simplification of your block diagram systems, this is still considered to be much simplified or much simplified version of your original system, as we will see in the examples today. The next we are going to see what happens when we do the vice versa for your branch point, where you take a branch point from after your system and you move it to a point before your system. So let's say in this case my branch point is after my system, which will be the AG, and if I move this branch point to before my system, then what will happen? So the point is that the thing we need to remember is moving a branch point from one position to another must not change the value that is coming out of that branch there, before wherever it is placed. So in this case, at my first position, the branch is giving me a value of AG. And if I'm shifting that branch point from after the system to before the system, I should still be getting the value AG, as you can see. And that is obtained by introducing another block in this picture. So this block also, you may think the number of blocks is increasing, which could increase in the infrastructure cost, but on the overalls, when we take the overall simplification of a much complex system, these things will lead to further reduction in infrastructure cost. So we will see that overall how these rule sets can simplify the overall design of your control system in the coming examples. The examples to follow. So the next I am showing what we are seeing here is what will happen when you move your summation from one place to the other. So here also we are going to see what, instead of the branch point, I'm using a summation point. So I'm placing the summation point after the system G in the first case, and in the second case I'm placing the summation point before the system. So the output of the summation is AG plus B in the first case, and in my second case also the output should come as AG plus B, so output of the system, and that is exactly what we see here. Good. And in order to do that, I have introduced a cascade block of 1 by G. In the second case, I'm taking the summer to before my block G. Okay. I'm taking the summer which is placed before my block G, and that is going to give me A plus B, and my output is going to be A plus B into G. And in order to move that summation to after the block G, which should give me the same output A plus B into G, I need to do the following. I need to introduce another block G, and that block multiplies with my A and B, and then it is added together. I get my A plus B into G. So these are very simple when you look at it, and the thing is when you apply them to your overall or your much complex system, you may face it a little more challenging than just seeing them as your rule set. Good. So let's move on to a numerical. We'll start with an easy level. So the things are pretty more obvious in that one. And then we will move on to a much more difficult numerical, and that should clear this topic for you. That should make this understandable and clear for you. So the question we have is represented. So this is a complex system. You can see there are more number of blocks and more number of adders, and there are some feedback loops here. Okay, so we have not seen what is the feedback transfer for feedback, how the feedback block diagram reduction happens. So that will be also discussed. That also needs to be discussed. So we have seen only the basic arithmetic operations and your branch point and your summation shifting. So these are considered as the most elementary block level reduction steps, and also you have something called as feedback reduction, which is part of the control system more, not the block diagram process. So that will be discussed in separately. So the question is to obtain your transfer function, and in this case the transfer function is given as the ratio of your output by the input, and in your case the question says the output is C of S, which means your input is R of S, and the transfer function is given by C of S upon R of S. Now, what is the rule set? So we have seen a lot of rules. We have seen around 6 rules on block diagram reduction. But how do we start? How do we get started with any question? So for any question, what we need to look for first is whether there are any overlapping branches or overlapping summers. So we need to look for overlapping branches, and we need to remove that overlap. And one way to do so is moving the branch point to either before or after the system. So when you do this, you will most likely you will get rid of the overlap by doing it in first term, or if maybe you need to do 2 times to get rid of the overlap. And also if you have any summations which are overlapping with each other or with the other blocks, you need to get rid of that also. So that is where you get started with, and then as you do that, your other simplification steps will become clear to you. So in this case, I'm having branch points 1 and 2 overlapping with one another. I can see from the question. So I'm going to move my 1 to position after G1 and after my branch point 2. And when I do that, I'm going to follow the rule set that we have seen just now. That is going to introduce a cascade of 1 by G1. Is clear? So when I move this branch point to this, I am going to now have 2 blocks, one of which is going to be the original G3, and the other one is going to be my 1 by G1 as shown in your diagram below. See, this is where we have applied our block diagram rule set, and now by doing so, I have got rid of my overlapping branches. So most of the questions will have overlapping branches which needs to be moved first, so that your other things will look very clearer. Once you do that, the simplification will look very, very clear to you, and it becomes very easy from there onwards. So now we will look at this remaining block diagram and see what other simplifications we can have, since there is no more overlapping branches and overlapping summations in this. So now I have 2 blocks in series, right? So we have my 1 by G1 and 1 by G3 in series. So that becomes my multiplication. That was the rule set 2 we have seen. So I have multiplied those 2 blocks, and then that is now written as G3 by G1. And now I have the rest of the blocks in this manner. Good. So now I have again applied another simplification here, which is my G1 by 1 plus G1H. So how did that come? Now that is your feedback transfer function. So when you have a block diagram, or you have a block diagram system in this manner as shown here, where you have this form. So this, anywhere you see this form in your control system, now this negative sign makes it a negative feedback. The response of this system, or the simplified form of this system, these two blocks can be merged into a single block, and the response function on the single equivalent block is written as g divided by 1 plus gh. Good. So that is what I have done there. So if you look back the video just few seconds back, you can see what was the block there. There was a feedback transfer block, and I have converted that into an equivalent single block transfer function, which is represented by G1 divided by 1 plus G1H. And my cascade block of G3 and 1 by G1 has been multiplied into G3 divided by G1. And if your question is using a positive sign, then that is obviously your positive feedback, and you need to accordingly change the equation with g by 1 minus gh. So the sign or the polarity is important for positive and negative feedback. So please remember those when you are doing the simplification on your own for any test. Good. So now my G2 and my G3 plus G1, they are now getting added because they were both connected to a summation block, and that becomes my G2 plus G3 by G1, and my G1 by 1 plus G1H is my negative transfer function. And now these two are in series, so they will get multiplied. So which means your overall transfer function is just a single block. See, now this represents your block diagram simplification. A system which was having a lot of blocks and a lot of summers is now reduced to a single block with many variables, and if you know the values of those variables or those systems, you can just multiply and divide and add, and you can have a single derivative function, and your entire system is now reduced to a single block. And this means a lot of you can make a lot of infrastructure savings, and as well as the cost savings when you go for the actual prototype development. A lot of amount will get saved. Miniaturization, it gets very small miniaturization. So the smaller the size, all these are the advantages of using your block diagram simplification for this control system. And if we are doing that by using certain rule sets, and if you follow the rule sets right, you get. So what if you don't follow the rule sets? You go wrong at one or two steps, and you end up simplifying the system. What will happen is, for the same set of inputs, so your R of S is your input, your output C of S will be different. So your overall system. So now we are looking at a medium level question, a little more difficult question than the previous one. So what will happen is, when I am sending my input and it is going to be computed at various stages, and I eventually am going to get my output R of S. And now when that output comes, I am not able to, that output will not be the same after simplification. So whenever you do the simplification, your output must come out the same as it was before simplification. And if that is happening for various test inputs, then your simplification is a success. So this is how we optimize your designs in your companies. All right. So we'll look at these questions here now. So the second question that we are looking at today is somewhat more complex, but we are going to follow the same rule sets or the same starting procedure which we did for the last question. So which is, we look for any overlap sums, overlap branch points, and if there are any of them, then we are going to simplify it. First we are going to move them so that there is no overlap at any point, and that is obviously going to open up for you a lot of simplification steps. So in this case, let us see, where do I see overlap? So here I am having both my summations and both the things are getting overlapped. So okay, the question slightly I have to alter it. Okay, now it is clear. So I can see that my overlapping branches are at where? My H4, right? So this H3 loop and my H4 loops are overlapping. I can say that from this. So what I'm going to do is, I need to overcome that. So I'm going to move that branch point H4 to a point either afterwards or before it, so where I can overcome this. So that is that is going to be my first step. And also I have summations of H4 and C of S overlapping. So I need to get rid of the overlapping in summation. Okay, so let's get started with this. So the first, before I can even go into the simplification, I see an obvious feedback loop here. Is that right? Yes, I have a feedback. I have a direct feedback. So I can simplify it. Here the signs are not given. Here it's not mentioned whether it is positive or negative. In those cases, we always go for the negative feedback system because my negative feedback system is my stable feedback system. And then what is the next step I'm going to do? I'm going to move the overlapping branch. So I can do it first also and then do the feedback simplification. So I'm going to move the overlapping branch to a point there, and that is still overlapping with H3. And my second shift to that point gets rid of my overlap. So when I move the branch point twice, I'm introducing two cascade blocks in my simplification. That's going to be 1 by G3 for shifting over G3, and then the 1 by G4 by 1 plus G4 H1 H2 for shifting over the feedback simplified transfer function. Good. So now let's write the simplified form in this case, and these simplified forms are going to represent in this manner. So your H4 is now cascaded with 1 by G3 and 1 divided by the feedback transfer function, and the rest of the things are the same. So now I have moved the overlapping branch points, and that has simplified. So now I'm seeing another feedback here, right? So that feedback is what? G2, G3 and the sum. So these are now this entire branch of G2, G3 and my negative feedback has been simplified into a single block of G2, G3 into G4 by 1 plus G4 H2. And then again, I have a feedback. Since no signs are given, I'm treating that as your negative feedback. And now this negative feedback function is given in this manner. Good, so that simplifies this. So after that, what do you have? That is in series with G2. So these three are in series. So H4 1 by G3, 1 plus G4 H1 H2 divided by G4. They are in series. So I'm going to just call this as variables A and B so that I don't want to overcomplicate things by writing a lot of variables for you. So when I write them as simple A and B, things look a lot more clearer for you when you see the next stage of simplification. So let's do that and see how this evolves to. And in my final derivation or the final transfer function equation, I replace my A and B with those values. Good. So now I have my A and I have my B. So now I'm going to interchange these summation points, and I can do that with minimal effect on other things because the summations are already associative, commutative and distributive, and here there is no block between your summation, right? So between these two summers there is no other block, so which means I am just changing the addition order of my addition, and that is not going to have any effect. I can do that without making any changes to the existing system of G1, A and B. And when I do that, what I have is my G1 and see my feedback systems are going to be now my G1 and A is in cascade. So that becomes a product function, and they are in cascade with the transfer function B. So with the system function B, which means that is your negative feedback system, which is given by G1A divided by 1 plus G1AB. And now that is in, so what is this? Yeah, that one. So you may think there is no effect of that branch on the system. No, it is having an equal effect as a transfer function because it is as a feedback transfer function because it is considered as a unity feedback, which means it's having a value 1. And I'm applying the same as the negative feedback function where my h is equal to 1. So my g by 1 plus h becomes this. So that is your simplification. Thank you. Thank you for listening. See you again. Bye. Bye.